Hello, this is Mr. Freund. We're going to have some time here where we need to be socially distant. So we're going to be doing this for a little while. It won't be a video every day. We're actually taking a pause from right where we left off on exponential functions. And I think just to start out the fourth quarter here, we're just going to work on our basic skills for the fourth quarter. So the lesson for today here is just a review on parent functions and transformations, and this is going to be your practice. You'll see it on your Google Classroom. You'll be able to print out the whole thing. And just for today, I'd just like you to get through these 6 practice transformations, and you can actually use your calculator to check your work. So let's get started here. So a quick review on parent functions. So what we see here is a quadratic. It's actually the parent function for all quadratic functions. It's because it's the most basic type. Here we have an absolute value function, and here we have a cubic function. And each of these has its own unique pattern. So I just want to remind you guys about what these patterns are looking like. And if you forget, well, this quadratic, remember, it has that vertical pattern of odd numbers, 1, 3, 5, 7, 9, etc. If you ever forget that, you can just make yourself this table here, or a similar table. Plug in your x values, get your y values, and you can see that it's going up 1 on both sides, 3, 5, and then it'll keep going, 7, 9, 11, etc. So when we graph that, we're going to make our memorable point the origin. That's right here. Okay, that's our memorable point. And then to quickly graph that, we're going to just follow the 1, 3, 5 vertical pattern. So 1, 3, and 5. And usually, to get a nice graph, you'll want to carry that as far as your grid will allow. So once we get I guess the path for our function, then we're going to get all the other points plotted in here. So there's our parent function for a quadratic, the most basic parabola. Let's look at the absolute value function. So we know absolute value means distance to the origin, and so when we plug in these values in for x, we get these y values. And so when we plot these points, we get this thing that kind of looks like a V, but basically it was a line where all the negative, it was the line y equals x, but now all these negative y values have become positive. So that creates that V looking thing. And so here's our absolute value function. Okay, the last one, we haven't seen a lot of this, but it's our cubic function. And again, I've plugged in some x values and cubed them. Oh, I didn't cube them properly as I'm looking here. Negative 3 times negative 3 times negative 3 is negative 27, negative 8, negative 1. And we won't be able to get to 27. We'll be able to get to this 8. But our memorable point on this one is that center point 0, 0. We can't call it a vertex because this is how these things look. Cubic functions. 2, 8, 2, 4, 6, 8. And then 2, 2, 4, 6, negative 8. So our cubic function, because it's to the third power, it ramps up a little more quickly here. So that's a tough one to draw. Just do the best you can as we work through these. So let's now talk transformation. So here's our basic. There's been a few changes here. Notice what's happened. There's this negative out front. That's going to reflect this over the x-axis. So it's going to be flipped over. This is going to move our parabola 3 left and 4 up. So I'll use a different color here. Let's use red. So I'm going to figure out where the memorable point has moved. That vertex has to move 3 left and 4 up. And it's flipped over, but it's still going to follow that 1, 3, 5, and then 7 pattern. Can't get 7 here on this grid, so we're just going to carry it off the grid here. And there's our first parabola. Okay, let's look at our absolute value function. We can tell it's absolute value, so it's going to have this characteristic. But what's happening? X minus 5, the positive 5 is the x value that makes this 0, so it's going to be right 5, and then a vertical stretch by a factor of 2. So whatever this did vertically, this is going to double that. It's basically changing the slope from 1 to 2. So if we take this memorable point, the vertex, and move it right 5, 1, 2, 3, 4, 5, and then double the slope, here's our vertically stretched absolute value function. All right, last one here, cubic function. So we're taking this and we have to flip it over the x-axis, reflect it over the x-axis. So this flipped, it's going to be up here, it's going to be, look at this flipped is up here, this flipped is down here, and then we also have to move it down 2 units. So once we flip it, it'll look like this, and then it'll move down 2 units. So here, and our first point is here, and let's see, this pattern, it changes 1 first, up and down, then it changes 7 the next time. So now I have to change this 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So now here's our cubic function after that transformation. Okay, guys, so that's your little review. Give some time, take your time on it, and you're actually going to, when you get done with these, try it without a calculator first, and then go ahead and plug those in on your calculator and kind of verify. You can use your table to compare points, and you can hit your graph and just get an eyeball for how the graph should look. And then if you have any questions, feel free to stop in on the Google Classroom with the office hours. Those are from 9 to 10. Okay, guys, good luck.